This is a video from the Cardano Summit Meetup 2021, and Joey joins us to talk all about the DeFi space and all of these hacks that have been happening in all these different various blockchains. Now, he also talks about how Cardano is facing all of these challenges and how it is solving them or potentially solving them with formal verification, and a lot of this stuff baked into the Plutus language itself. So a lot of the smart contracts that are being written at the moment will have a lot of these security benefits baked into it from the get-go. So let's get into this presentation and find out exactly what's going on.
We have Joey Nishad at the front here. Yay. He's a security expert and co-founder of Doco Life. Is that how you spell it? Say it? Yep, okay. He's a philosopher, a venture technologist, strategist, researcher, security advisor, and educator. And he's going to talk to us about DeFi hacks, some of these crazy hacks that have happened in the DeFi space over the last year. I think you're just covering this year, right?
Yeah, last week, couple of months actually.
Okay, yeah, last week, couple of months. Oh, yeah, I saw the stats and was like, whoa, I didn't even hear some of these hacks actually happened. So we want to talk about this because DeFi is coming to Cardano, and we do want to monitor and watch what's happening in other ecosystems, and we don't want this happening in Cardano. But thankfully, the Cardano ecosystem is built on Haskell. It's formal verified language, so it's built very differently. I know there's about 14 or so different decentralized exchanges or DeFi projects that are being built at the moment, and 14 might be a conservative number. I'm sure there are many more coming to the blockchain. So, Joey, come on up. Thank you.
Cool, Pete. Thanks for the intro. That saves me trouble, right? So basically a quick overview of what we're going to do, right? So this presentation is like kind of geared more towards looking at the security in the blockchain ecosystem rather than how you could be safe online type of perspective. So there is an element where there you can look at a project and go like evaluate the security implications or the security posture of that project before you invest in it or before you participate in it, but it's not really about how to be safe online. This is more about raising the bar for the security environment within our blockchain ecosystems, right? So having said that, let us start. Apparently I can't make this work. I pressed the wrong button. I think I pressed back. The green button. It's not doing anything. Oh, that one, the big one. Okay. I thought it was some logo. Cool. So that is how competent I am. So there we go. You guys still want me to do the talk? Right. So I'm going to have to move this a little bit because, okay, I can see that. So, okay, so just to get an idea of what we're going to do here, right? We will talk a bit about DeFi and blockchain security at a high level, right? And we will basically try to get to know each other, where we are coming from, like what our background is, what our involvement in blockchain is. And we'll hopefully make friends, right? And have fun at the same time. Does that sound good? Yes. Great. Okay, so to get a feel for where you guys are coming from, right? So there are different levels of involvement we have in this ecosystem, right? So, for example, if you're an investor or a trader, right, you just expect things to work, right? You just want things to work so you can go on about your business of investing or trading, right? So how many of us are in that category here? Cool. And then from there on, if you go one layer deeper, right, there's basically people who are involved with how these things actually work, right? So more from a developer perspective. So how many developers are in here? Fair enough. So basically, the how do things work and making things work is kind of like developers wanting to be developers, looking towards understanding more that type of category, right? And then we have researchers, right, who basically always look at new opportunities and see, like, how can we do things better, or what more can we do with this, right? So is there anyone who would look at themselves in that view as a researcher? Yeah, cool. Very diverse audience, awesome. And then there's the people like me, right, who look at things, something that works perfectly and go like, hey, how can I break this, right? Any of us around? Oh, that's lonely. Fair enough. Okay, so that's basically like, the broad categorization of the kind of interactions where people come from into this space, right? So now that we have a rough idea where we're at, let's have a look at what we're going to talk about. So we're quickly going to go over like what really security is. I mean, we intuitively all know what security is, right? Just to get a common shared understanding of this, right? Like what security is and why do we really need it, right? And we're going to talk about how to do blockchain security at a higher level. And we look at some nasty hacks that Pete was referring to. And we're going to look at how Cardano does things differently. Right? So that part is actually quite significant in the sense that Cardano approach to security is somewhat unique in this ecosystem, currently at the very least, because Cardano is coming from, at least in this aspect, it's coming from a background of academic formal verification type approach applied to security as opposed to just patching everything that breaks kind of approach, right? So that'll be interesting. We'll look at that as well. So does that sound reasonable? Okay, so fair warning, I might actually run out of time, so I might have to kind of skip through some of the slides, so please forgive me if I have to do that. But having said that, we should be good. Okay. Now, why do we need security, right? Why do we even care, right? So, there are many reasons to this, but one of the fundamental reasons for security is that we just want things to work as they're supposed to, right? We don't want things to not work because someone did something they shouldn't have done, right? So I would say access to function is sort of like the most important aspect of security because we want things to work the way it is supposed to work without someone being able to change it and screw it up for everyone else, right? So, and the second thing is identity, right? Like whenever we interact with any ecosystem, right, we have a certain identity. And like, for example, like your assets, right? They're your assets, right? They're tied to your identity, right? So you don't want someone else to be able to take your identity and take your assets, right? So security is important for this identity aspect, for you to like maintain your identity within all your interactions, right? And then related to that to some degree is your privacy, right? Now, privacy is an interesting one, especially in this space, because like, for example, right, you don't go around with your bank statement printed on a t-shirt, right? But hey, we have public ledgers, right? So in blockchains, like the privacy is actually a significant concern, and it's a significant security impact as well, because your financial information can be leveraged by various parties to put you in a disadvantaged position, to say the least, right? So the privacy aspect is a big one. And so what all this boils down to is freedom, right? It's an expression of yourself. How do you interact in this world, right? How do you achieve a level of prosperity that you can be happy with, right? So in a fundamental sense, security is very important to freedom, right? I mean, it's just like property rights, right? If you didn't have property rights, imagine the world, right? So this is kind of why we need security, and this is why it's important. Like all the things we take for granted for the most part is actually being underpinned by security. So this is why we should care. Yes? No? Good. So, is there absolute security, like ever? Absolutely not, right? I mean, absolute security is an ideal, right? So, when it comes to security, what we do is we basically draw the line in the sand somewhere, and we say this is acceptable, and anything beyond that is not acceptable, right? So this is what security truly is. There is no such thing that is truly secure. There's no system or process that is 100% secure, because given enough time and effort, you can always find a way around it. So it always boils down to time and effort. So the question is, where are we going to set the bar? At which point are we going to say there is a system of negative repercussions and a system of disincentivization to make sure that this bar is not breached often for it to be a problem, right? So basically, security is always a work in progress. As ecosystems change, security criteria change, the bar changes based on expectations. It's always a fluid process. There's no such thing as absolute security. We can't wipe our hands and say we're done, right? Now, what are the main important things about security? Like, when in technology space, when we say security, most of the time people tend to think in technological terms, right? People tend to think that it is this particular piece of technology that is making things secure. Like, technology is a part of it, but it is more of a facilitator, right? Ultimately, security is about people, in terms of people who are developing solutions, in terms of people who are using solutions. And depending on how these people do what they do, it impacts security in a big way. Like, for example, like one of the problems that you find in, like, say, corporate IT security is that some security solutions tend to be creating so many constraints to the point where your user base becomes people most incentivized to actually bypass the security to get what they want to get done, right? So that is not a successful model. And it is basically a disconnect between technology and the people, and to a degree processes as well, right? So this is something that I want to point out, that security is the amalgamation of people, processes, and technology. It's not just one aspect, right? Unless all these three things work synergistically to achieve that security bar that we have set, it is going to fail. So this part is very, very important. You can't consider one aspect without considering the others, which is basically, if we do that, we are setting ourselves up to failure. Right? Now, basically, the security environment we're operating in is essentially this people, process, and technology operating at a higher scale, right? There are multiple entities with these three things interacting with each other, which creates a complex security ecosystem. So they don't have the same approach or the same balance in all three things, but they interact together in one ecosystem. So this creates interesting situations. So across the board, as an ecosystem, as a high-level goal, what I would say that we should be looking at is to raise the bar in security across all these dimensions at all these different scales as we can, knowing that it is an ideal and it is never going to be perfect. So when it comes to blockchain, people have these preconceptions about blockchain technologies. So one is about decentralization, right? So is the blockchain truly decentralized? So who thinks the blockchain is truly decentralized? Well, not many people.
Depends on the chain.
Well, exactly, right? Exactly. So the technology can be decentralized, but it really depends on who owns the nodes at the end of the day, right? So this is the thing, so blockchain can be decentralized, but it is not guaranteed to be decentralized. And this is something that people tend to miss. And so along the same lines, the second one is that, is blockchain truly global, right? I mean, yeah, it can be. But if all the nodes are run by this, one department in one country, is it global? No, not at all, right? The blockchain infrastructure can be global, but it can also be very local. So, I mean, there are some L2 solutions that might have 6 nodes, in one lab, right? I mean, is that decentralized? Absolutely not. Just because it is using blockchain technology doesn't make it decentralized, right? And global. So when you're looking at blockchain as a solution to a particular problem that requires decentralization and the globalization aspect of it, global participation, I would say, you need to look at who's running these nodes and where are these nodes running on. Because the technology itself doesn't guarantee any of these things. Now, the second part of this is that the secure by default idea is that, I mean, really, like, how much feedback do you have on the blockchain systems or ecosystems when something goes wrong, right? Like, how long do things go undiscovered when things go wrong? Now, someone might say, hey, it's a public ledger, anyone can see it. But I mean, who's looking? Who's combing through this data, right? I mean, yes, there are companies that comb blockchain data like Chainalysis and all these guys, right? That run very high-level analytics on like tons of different blockchains, right? But they do it for different purposes. They're not looking for security problems. They're basically helping their clients gather intelligence on what happens in these blockchain environments, whether it's intelligence agencies or tax departments or like corporations or whatever, right? So right now, the feedback and discoverability on the blockchain in terms of security anomalies and security events are somewhat in its infancy, in the sense that we don't really have the same level of technology that we have elsewhere, for example, in like network monitoring, for example, right? Or host activity monitoring. We don't have that level of technological maturation in the blockchain ecosystem that we do in other places. So this is somewhere that we can do better. Right? And then like the whole accountability, liability, and recourse system, right? It is decentralized, so who's accountable? Is that a guy who runs the nodes? Is it someone who made a fraudulent transaction? Like, is that the guy who hacked something? Or is it just like, can you sue a smart contract for losing your money? Right? So the decentralization and globalization also brings distributed accountability, multi-jurisdictional players, and like in many cases, like no clear liability on any party, which makes it an interesting situation because most of the time you have no recourse under those conditions. So this is again something that is an interesting challenge that we are going to have to solve moving forward as these ecosystems mature. Because right now, right, like with a lot of you'll see this with a lot of hacks, right? So you put your coins, you stake your coins with some smart contract, right? And someone like exploits the vulnerability, and suddenly the tokens disappear. So what do? You write a strongly worded letter to the smart contract, right? So yeah, I mean, there's really no real established mechanism of recourse. So this may be legislation that is uniform internationally. This may come in the form of a mature insurance industry that basically underwrites these things, or could be a combination of both. Each have their pros and cons, but definitely this is something that we need to invest and price more into these ecosystems. And then last but not the least, you have the issue of censorship, right? So one of the reasons why I want to mention censorship here is that so a lot of the L2 solutions that depend on a smaller number of nodes implementing this L2 solution and smaller global distribution are not as censorship resistant as an L1 solution, right? So think of it this way. If you have an L2 solution that does this one thing, and it has a dedicated group of users who do that one thing there, like from the perspective of say a government agency, for example, right, or for an authoritarian regime, whatever, right? For them, taking the nodes that implement this L2 solution away is more feasible than, for example, disrupting an entire blockchain like Ethereum, for example, to achieve that purpose, right? You don't want to derail a train to get one person on the train, right? So there is safety in numbers for these L1 solutions because there is a diverse group of people from very different places doing a lot of different things on these blockchains. So to deny the experience of one product that is operating on it taking out the entire network for that purpose is not really feasible. There's going to be a lot of blowback, right? But if it is an L2 that has a limited number of nodes, limited distribution, very limited user base, and there's one function or limited set of functions, to take that out from a censorship perspective is a lot more feasible. So these are things that we need to consider when we look at these technologies, because we tend to look at these things as, oh yeah, this is secure and private by default, we take it for granted, but that's not the case. So that's kind of what I want to point out on this slide. So, privacy aspect now, right? So like the gentleman who was doing the presentation on taxation was saying, right, the data, when there's public ledgers, when all the data is on the blockchain, right, they can have access to it, right? But so does everyone else. So this is a problem, right? So like if you think about your bank records, right, like your transaction records, like who has access to them, really? Like maybe your credit card companies, right? The banks themselves, taxation authorities maybe, right? But does some random scammer in Nigeria have access to your transaction history ordinarily? Well, I did say ordinarily. So no, right? But when it comes to public ledgers, anyone anywhere in the world has access to it, and they can identify you as long as they have your public key, like your addresses, which are basically your public keys, right? So essentially, if I go to a coffee shop, right, and pay in crypto, the barista or the cashier in the coffee shop, right, can look at my entire financial history, more or less, right, for the past and the future, if I keep using the same wallet address, right, and they will know what assets I'm holding in the past and in the future, again, right? So I have absolutely no privacy. It's sort of like giving read-only access to my bank account every time I buy a coffee, right? Like, I mean, does that sound like a desirable situation? I mean, I probably wouldn't want, like, my barista to know my OnlyFans activity, right? I mean, like, some things need to be private, right? It's funny because when I was giving that talk at another event, someone said that, privacy actually protects marriages. Right? Which is a fair observation, I'd say. So that is the problem. Like that is the problem with the public ledgers and privacy expectations, right? Like, I mean, there's this sort of misconception that crypto is private. It's not. It's a public ledger. It's actually less private than other things by default, right? So we need to have mechanisms built in that preserves privacy while maintaining compliance. Like the previous taxation agent case is a perfect one, right? You need to be able to preserve privacy, but you need to be able to also give access to a taxation agent to all your records without having to record every single transaction yourself, right? So there has to be a mechanism that gives you the choice to do it, but not some guy in Ghana just basically who's woke up in the morning and thought, hey, I'm going to scam someone, right? So this brings to a bigger picture of what large-scale analytics can do on the blockchain, right? It's essentially large-scale analysis like companies like Chainalysis are doing and intelligence agencies are doing, right? So what happens here is that they run large-scale analytics, or they can run large-scale analytics, because I don't want to speculate, right? And you can basically look at broad-scale patterns. You can look at like what kind of purchases you're doing, what kind of vulnerabilities you might have depending on your purchase patterns. Right? All this data is on chain for everyone to see, right? So there's a huge privacy implication there as well. I mean, I can imagine there'll be multiple regimes in the world who would love to have this level of analytics on their citizenry. So again, a problem we need to solve in terms of security in the blockchain space. This time is not me. Oh, it's gonna work now, isn't it? Oops. All right. Yep. So, I mean, this is one of the aspects I want to mention, like it's about people too, right? There's massive innovation happening in the blockchain space. I'm trying to speed up a little bit, otherwise we'll be here for So there's massive innovation happening in the blockchain space, which is a beautiful thing to see. And, but at the same time, when massive innovation happens, you always focus on functionality, less on security, and less on reliability and things like this, right? So the posture and the attitude we apply to these things is also kind of important. And the skills and competency come into play as well, right? Like right now in the blockchain space, there's a lot more need for security engineering than there is. Again, that boils down to the level of innovation happening, amount of available skilled resources, and all these things. So this is somewhere we need to ramp up as well. And the security investments need to be made, right? These things don't happen by themselves. And we need to price security into the activities that we do, because there's a cost, right? And what are the repercussions, right? This is the other thing. Like, I mean, it's in some ways it's a little bit Wild West, right? We don't really have established means of negatively reinforcing or disincentivizing people who basically go out there and try to exploit and violate other people's rights, right? So this is another area that we kind of need to look at, and this is not about technology, this is more about people. Right, so when security, we're not going to get it, right? So when we want to do security, these are like the broad aspects that we need to look at, right? We need to look at the expected function of the system. We need to do the adequate threat models to identify and understand what these systems are going to be vulnerable to. And then we come up with a good security design, and then we obviously implement it. But no implementation is ever going to be perfect, so we have auditing. So auditing happens at multiple levels: penetration testing, code auditing, functional verification, right? So, like, functional verification is very interesting because it has an impact on all those areas, right? In terms of monitoring as well. So these are the pieces that we need to actually have a solution that is secure from a technological perspective. Now, let's look at when things don't work, right? So let's assume for a moment we don't have the data right yet, maybe. Some of you might, right? That DeFi hacking happens. And so what do DeFi hackers do, right? They steal money, right? Tokens, money. And they steal private data, right? Your transaction histories, your transaction records. Like, if you're a trader and if you have a successful trading scheme, it'll be beneficial for someone to have it, right? And then what that creates is that if someone else uses your trading strategy, the total accessible amount of wealth that is accessible or profits accessible through that trading strategy will diminish when more players enter it, right? So your private data is important even from trading perspective. There's always denial of service. People can make things not work. So basically you lose access to function that we were talking about before. And then there's people who just do it for fun. They want to learn. They just play around, right? And sometimes they break things, but don't mean any harm, right? And then there's also the groups that just want to go and put like graffiti on your grandma's head kind of stuff, right? So it's just basically what you would consider antisocial behavior for whatever motivations, right? And then there's also another aspect where exploiting vulnerabilities in DeFi protocols as a trading or an investment strategy is hugely profitable, right? So people do that. People do that with tens of millions of dollars as a professional trading or investment strategy. There are multiple crypto hedge funds that do this, right? And is it illegal? I mean, is it? Who knows? Like, where's the line? Where do you draw the line, right? I mean, if you see someone going out there and performing some financial activity that has some vulnerability that you can interact with in a legal manner and profit from it, it's technically not illegal, right? So the same applies to DeFi as well. Like a badly written DeFi protocol can potentially be exploited under the right conditions to make a lot of money. So it is hacking, but it may not be illegal or it may not be unethical in some ways. So this is basically the legal side or the mainstream side of DeFi hacking. And this happens right now. Right? There are multiple crypto hedge funds that operate on this principle and quite successfully. So that's one aspect of it. Right, so we'll quickly go through this slide. So this is just a snapshot in the last couple of months of all the DeFi hacks, right? I mean, not all of them, but the major reported DeFi hacks, to just give an idea as to how common these things are, right? And actually, the last one, the 21st September one, I actually added it like a couple of days ago because it just happened recently, right? So this is how common DeFi hacks are, right? So the Poly Network hack, for example, it's got a lot of press. And it's not really a sad story in the end because 611 million got stolen, most of it was returned. There was a bit of interesting drama happening through that whole process. My understanding is that the gentleman who stole that money, or who hacked and commandeered the money, right? He ended up getting a job with Poly as the chief security officer or something like this, right? And there were interesting soap opera moments unfolding on chain where like someone put a comment on one of their transactions to this person's wallet address which said, hey, something along the lines of, hey, Tether is going to burn your USDT, right? So he moved it over to Curve, and then he basically sent 13.37 ETH as a thank you for this guy for giving him the tip. So there was like a whole bunch of like drama that was unfolding around this thing. So it was quite entertaining to watch. So in some ways, public ledgers can be fun too. So these are basically like to give you an idea of how prevalent and how much of financial impact these things have. Right, now I do have some slides that go into the actual specifics of the Poly network chain attack, but I wouldn't have time to go through it, so you're welcome to have the slides and have a look through it. And I mean, the Poly network attack is so common that there's multiple people talking about it, so if you want to have a much more in-depth view, I'm sure there's someone who's giving a talk about it. So this is a Poly network hack, basically, the technical details of it. So to give it in a nutshell, what happened in the hack is that it was a set of complex smart contract interactions, and the privileges and trust between these smart contracts was not very well thought of as to who can do what, so that got exploited. That's basically what happened, in a nutshell, right? So now the more important part, like how does Cardano do these things differently, right? Now, one of the more powerful tools that we have in our arsenal is what we call functional verification or formal verification for functional correctness, right? So what this is about is we look at a system, we model it effectively, mathematically model this system, and then we reason about this system in a way that we can come to conclusions that are mathematically and logically rigorous to show us the behavior of the system. So what happens here is that you can literally reason about a system the way you would reason from axioms in mathematical proof. So it's a very, very rigorous process. But this is very difficult to do at scale because the complexity is a problem here. So Cardano has, from the very beginning, have a very formal approach to designing their technology. So, for example, like there's formal semantics that was already done for the Cardano like blockchain function, including the virtual machine, even before a lot of it was implemented, right? So I know there's a lot of complaints about Cardano being slow to implement things, but this could be a reason for it, right? You take your time to do the proper formal verification of things. So it is not necessarily a bad thing. They're putting in the time up front. So this is somewhat unique in the blockchain ecosystem where generally people try to get the functionality through, and these guys are basically thinking through the security aspect of it and the reliability aspect of it, and basically doing the things up front to have the tools know what you're doing later on, right? So the KEVM formal specification was created to model the functions of the EVM Ethereum virtual machine in a formal setting, so you can actually reason with it, right? And out of that reasoning, what Cardano guys came up with is a virtual machine implementation that addresses some of the potential gaps or weaknesses that could or may theoretically exist in the EVM virtual machine. So this is where they came up with the IELE, which is essentially an auto-generated virtual machine based on the work that they did with the KEVM, and it is not handcrafted, it is auto-generated from the semantics that they have come up with. So this is a different approach to how most things get implemented. So this is promising from a security perspective because you're starting from a very rigorous standpoint. So the IELE goals are to auto-generate VMs using LLVM, right? And you would have a verified VM where you mathematically reason about the VM and you know exactly what the VM is going to do. The specification is tight, the functionality space is explored. And for this VM, you can code in Solidity, Viper, or Plutus, right, for now, and there could be other stuff. There's a better gas model, which was a goal of IELE. And there was also, they took into consideration from a coding perspective to make code easier to read. Because at the end of the day, the code may be open source, but if no one can read it, right, nothing really gets done. And the upshot of all of this was this ecosystem of tools that allows you to come up with easier proof for correctness for things that you build on this. So this is basically a unique difference I see in Cardano compared to some of the other blockchain solutions out there. And this is very promising from a security standpoint. And the K framework is the runtime verification framework that they have built to make a lot of these things possible. I don't think we'll have time to go too deep into this, but basically, Grigor Rosu, who is the guy who's the brain behind a lot of these things, he's an academic, and he's basically involved in a company called Runtime Verification, which does formal verification for mission-critical systems with NASA, Toyota, Boeing, and a lot of other military projects as well. So they put their expertise into building this K framework that is basically used in Cardano, that is something that they built over like 15 or 20 years of basically doing the formal verification for mission-critical systems. So that's pretty much it. Sorry about rushing through a lot of slides and missing a few. So what did we learn from this? Anything at all?
Oh no, I learned that I don't know very much. It's really the answer.
Trust me, this is something I feel every morning when I wake up. Especially when I talk to my kids, that's how I feel. So I'm with you. Any questions?
Has there been any security that you're aware of breaches in its history to date?
So the situation is twofold, right? So the first one is that the DeFi ecosystem for Cardano is now just coming online, right? And we have like a good solid base for doing security on Cardano, but it still needs to be used by people. It's not automatic in many ways. Some of it is automatic in terms of the formal verification that is applied to the IELE virtual machine implementation and the blockchain implementation. But when it comes to coding the smart contract, if someone doesn't use the formal verification features available through Plutus, for example, you're still going to make bad apps, right? You can't stop people from making bad apps. And because the DeFi ecosystem is not very mature, we don't really have too many examples, right? So we are essentially starting from ground up, and we have the right tools to do it the right way. I mean, that's basically the key takeaway from this. When you look at other blockchains, we know how badly they've screwed up. And here we are starting from this really good base. Let's not make the same mistakes. Right? Yep.
So you're probably familiar with Tornado Cash, which is a
Yep.
solution to obfuscate your Ethereum address.
Yep.
Is there a project on Cardano that's doing that, trying to do that?
I'm not aware of anything like that at the moment. But then again, I'm not an expert. Pete would be the one to ask. It's but on Ethereum, there's multiple solutions. There's Tornado Cash, which is transaction-based. There's basically ZK Money, which is based on the Aztec network, which is basically L2, right? And you have Railgun, which is L1, which lets you have like private balances as well as DeFi interactions. And then there's Offshift, where we haven't really seen anything much on it, but there's a lot of interesting chatter about it, right? So on Ethereum, there's multiple solutions, right? But on Cardano, I haven't heard of any such solution yet, but it is something that someone should implement.
Yeah, there'll be one, yeah.
Exactly. And you can learn from all the learning process that happened on other environments and come up with a better solution, or at least a comparable solution to some of the best that is out there from the word go, because you have the advantage of being a late entrant into the field. Any more questions?
Sorry, I got another question. If future applications decide to be multi-bridged with different blockchains, is it possible for these apps to take on the security of Cardano or a blockchain to another blockchain?
I mean, yes and no. It depends on the scope. Like generally what happens with like this type of solutions is like, it's like a chain, right? Like it's always the weakest link, right? So like this is where the problem is. So an end-to-end system can only be secure as its weakest component. So in some ways, yes, you could do things more securely by offloading some of the functionality off to a system like, off to a blockchain system like Cardano, where they could do like formally verified stuff. So you're doing less on the more insecure side and doing more on the more secure side, or potentially can be more secure side. So yes, but by the same token, if they do something silly on the insecure side, that can end up compromising all the other stuff. So yes and no.
Any more?
I have a, maybe, Mike, yes. Thanks, man. This is
Nice and
sort
close.
of maybe a random-ish question.
Mm-hmm.
But like in regards to, you know, the wallet addresses that we have, obviously if we lose it, we can't access our wallets again. And that's in relation to like obviously absolute security. How does that properly tie in then? Is there like a proper solution in relation to that?
Okay, so a couple of things, right? So what your wallet address is, in general speaking, right? What your wallet address is a hash of your public keys, right? So it's just basically an identifier to tie you back to your private key in a way, right? So there are ways to transact in a way that your public address or your identifier, so to speak, is kept private. And like, so for example, zero knowledge proof is a technology that can be leveraged for this purpose, right? And so a lot of the privacy solutions on Ethereum, for example, is relying on zero knowledge proof. So yes, it can be done, and to what degree will depend on whatever the solutions that we'll see. But yeah, you can do it.
Oh, okay.
Thank you.
Right, we've got a question from the chat as well, online chat.
Yeah.
How does smart contract audit tokens work within Cardano? So how's
Sorry, could you say that again?
how's auditing done with smart contracts on Cardano?
So basically, on Cardano, like the language, like the Plutus, for example, and the K framework provides some ability to do formal verification-based auditing on smart contracts as a part of the platform features. So this is something unique to Cardano at this point as far as blockchains are concerned, right? And a lot of auditing companies have their own tools and their own people and all their own methodology. So there is no such thing as like a one process that everyone uses. But generally speaking, from a mathematical standpoint, it is very straightforward in terms of how one would go about doing a proof of correctness in function. But in reality, how you actually start implementing that process or achieving the same outcomes doing different things really depends. Like you would basically either have experienced auditors look at the code and try to identify vulnerabilities. You might do fuzz testing. You might do some type of automated fuzz testing or stress testing of certain components. There will be like, you can do functional verification. or formal verification from the design phase onwards. So there's multiple things that one can do. There's no such thing as a one single process that gets applied across the board. But Cardano does provide more infrastructure for someone to do formal verification and proving functional correctness than some of the other solutions that are out there.
Okay, maybe time for one more, but it's just about our lunchtime now. So I think we might wrap it up if we don't have another question. Right, thank you very much, Joey.
Lunch. Cheers.